It should be going. Talk. Potentially more people are coming. We'll see. I just want to do a quick background on what today's talk is, because there's multiple things going on that it might be worth people in the room being aware of. One of which is I'm from the Division of Data Sciences, and I have a mission to get faculty to work with us to add data science to their existing classes. Some of the other people in the room are the Research IT Reading Group, which meets here regularly, bi-weekly at this time, and covers all sorts of interesting topics about sort of campus technology, and has people that are, stakeholders and campus technology and different platforms. They have a website, and their talks are archived, and you can look up what they're doing. Sometimes they have a reading, and you can they discuss the reading. It's a little bit more of a roundtable discussion. But this talk is also just openly listed to the public as an AIS educational talk. And it's also part of the Data Tech Diversity Week. So there's a series of events this week, some at BIDS, some at other places. Women in Data Science was Monday. There's like our training in Spanish on Friday. There's a whole bunch of different events going on. So this is part of it. So part of what I'm going to touch on in this talk is a thread of why we think teaching this way encourages diversity and increases access and includes more people in the project of data science. So just so that you know that that's like where I'm coming from with this a thread in this talk. And and so overall I'm also just interested in recruiting people, and I'll be the format is I'm gonna talk slideshow for 40 minutes, and then I'm going to do some workshop-y stuff at the end. And I know I have a few people that I met last time that I'm hopefully gonna try and be like, okay, here, try this, use the skills, open the Jupyter Notebook at the end. So there'll be a little workshop-y part at the end. And hopefully you guys will engage in discussion in the Research IT Reading Group if you guys have critical questions or things we should think about. Feel free to chime in at any point. Motivation for the talk. So our motivation is all different areas of academia across the university can be enriched by data science. Data science is not a project of computer science and statistics. Data science is like a welcoming project that can touch humanities, can touch social science. There's really awesome seats in the front row. I know you probably don't want to hear that, but we think that all students at UC Berkeley can be enriched by learning data science. And our approach is if you can get them early at Data 8, the rest of their academic career can be enriched. What they could be doing as an applied work or in their thesis could be even more powerful. We have a vision that there's an infrastructure that's built by our team for this big class, Data 8, and I'm going to walk through this, but using that tool to get as broad a reach as we can across the campus. And the main thing that we're using here are Jupyter Notebooks. And the reason we're using Jupyter Notebooks is it's a low barrier to entry. It's a very simple way to get people started in computing. So outline the talk. I'm going to talk about me and what we do in data science education program. Then I'm going to talk about motivating this equity and access. I'm going to talk about Data 8. We can look at some of their statistics and diversity. Then I'm going to motivate the steps of what I call the pedagogy platform. It's a set of things that work together. And then at the end, we'll do a workshop and try and get people with their laptops out to get their hands on deploying this. So on the diversity note, what's important for us about Division of Data Science is we work with a lot of different types of instructors. So we have a program to outreach to faculty to put little bits of data science into their existing classes. And this can be in many different domains. History, demography, there's some in art, there's been some in English. So social science, humanities, but also working with Earth and planetary science. We're now have a big impetus to move into engineering. So we're working with all sorts of different domains. And we're thinking of like all these pieces are fitting together as sort of an overarching bit of pedagogy. It's not just one class or one set of things. It's like the different forces we can bring together. And so we're trying to build coalition of faculty that are interested and have something vested in this. We reach out to domains by people teaching connector classes. So people are in the main introduction, Data 8, and then there are a set of connector classes that are like domain-specific expertise. That's when you're learning data science. Then we have modules where students are just in any other class they may have signed up for, not knowing there was data science in it. And then we will add a little bit of data science in a really accessible way to an existing class. And we're building new curriculum over time. So our vision is like we're building data science in collaboration with faculty across campus. We also work with a lot of different kinds of students. It's a little hard to describe this without experiencing it, but a lot of the work we do is with amazing student volunteers. And the work that I do here in like trying to recruit faculty to build materials for faculty is largely done through students as well. And those students are coming from applied math, from cognitive science, from a whole different types of majors that are working on this. We have about 20 student staff, about 70 students volunteering for credit, so there's a big team of students that are working on this. There's a peer consulting team, so you can go into Moffitt Library as a student, get help on your homework from other students that are going to help you do your data science. There's a peer advising, there's a new major that's coming out, so the whole peer advising part of it to people navigate which classes they should be taking, what they might be interested in. And then like for computer science or biology or chemistry, there's a data science scholars program, and that has 3 sections, one in the Data 8 class, one for people doing research, and one for sort of career development skills. One of the biggest things that we've done for outreach is collaborate with the American cultures classes, and I demonstrated a bunch of this in my class that was a couple weeks ago. This is a requirement for all students at UC Berkeley to take an American cultures class. They're really big classes that have a diversity of students who are in them. So students from all majors are in these classes. Students have signed up for American cultures class not thinking that they're going to do computing in the class. And so we take and integrate some basic lesson that's related, that the instructor motivates, that the instructor comes up with how it relates to their class. And we build some Jupyter notebooks that are simple enough that somebody who's never done computing can use them. So some of our really successful ones, so sociology and psychology, these have run multiple times. The first one is a neighborhood mapping project where students actually go out into the neighborhoods and gather some data, and then the Jupyter notebook pulls in the student data, and like they can all look at their classroom shared data. The psychology module looks at implicit bias, and so students can take the implicit bias test and then take a national data set of the implicit bias outcomes across counties and then map that on different types of outcomes. We currently have a class that's developing a module on mass incarceration and how things have changed in overcrowding in California prisons. 2 ones that I'll show later that are just deploying right now this semester. There's one on international development, carbon intensity of different countries. There's environmental science one on pollution, asthma, as relates to different zip codes. And then previously there were ones in English and art, one on Chinatowns, one on data arts. Greg Niemeyer is a really interesting professor who created some interesting modules as well. So these are like an amazing place to say if these notebooks can succeed in these classes, then we're really making data science accessible to people who wouldn't normally get to touch it. But the biggest push that we do is through Data 8, a very large class. This is Wheeler Hall that's full. The current semester, it's 1,500 students, and there's something like 900 that fit in Wheeler Hall, so it's like full to the seams. And I can walk through a little bit of what it takes to deploy data science at this huge scale. what's important is when they design this big of a class, and they design this class at this intro basic level, they said, let's not make any math required, right? No math 1A, 1B. The math that you took in high school to get into UC Berkeley is enough math to start with. No programming background required. We'll teach you the basic elements of programming as we go along in the class. So these are two really big assumptions about accessibility. The important thing that I'll then say is they then designed this platform so that the students don't need any specific computer, they don't need any specific software licensing, they don't need anything installed, any computer with access to the internet. And there is a Chromebook loaning program at the library, so students that don't have a computer or their computer stolen, they can go and check out a Chromebook. So this is a starting point for this class. So how can we increase the number of students doing a computer science? By removing these barriers that are there for the engineering type classes. So this data is a little bit old and I need to renew it. It's from 2018, a year ago, but we looked at the survey. There's 74 different majors in Data 8, so pretty broad. The most likely majors are, predictably economics and STEM, people who are already quantitative, but there's a pretty long tail that goes into humanities and social science. And it's that long tail that's really does help us get really interesting people, because we recruit really interesting students out of that continue to work with us and take other classes, head into the minor other places. Gender balance. So this is the class growing, 100 people in the first offering, 1,000 people spring 18. As I said, now it's capped at about 15 or 1,600. So exponential growth runs into class size at UC Berkeley. So we don't have class size to continue exponential growth, but gender balance is definitely has generally been achieved over the class and seems like it's continuing. Again, sorry that the data is not up to this semester. Underrepresented students. So this is something where obviously there's more work to do. There's a long story about underrepresented minorities in STEM and what are the different challenges and what are the pathways to getting more involvement. There's other workshops at AAS that I encourage you to go to. Biology scholars come, chemistry scholars come. They've all done different things to redesign their classes. So the percentage here looks like, in the biggest class around 9%. This is higher than computer science classes, higher than the engineering classes, but lower than the UC Berkeley percentage, right? So we're somewhere between making things more inviting and more accessible and where we want to be in terms of touching the true diversity of UC Berkeley. So there's more work to do here, and we're still tracking this data and thinking about more ways to make it more inclusive. So just really quickly showing how it's designed. So Data 8 runs on its own website. They don't use B courses. So this is the Data 8 course website. And then over here, this is the textbook that we'll look at. These are chapters in the textbooks, and these have interactive Jupyter notebooks in the chapters of the textbook. But then these are the main Jupyter notebooks as they're deployed. So the students just go to the website, they see a link, right? The students don't see anything that says Jupyter anywhere. They don't see anything that says GitHub anywhere. And that's what I'm trying to motivate to you. It's it can take a while till the students in the class will ever see any of the elements that I'm exposing to you here, right? So students just see there's a website, there's a link with my homework. Let's see if this will run. So here's a video just student goes to Data 8 website. Then they're going to click on a lab. They're going to stay in the browser window that they started in. They're going to log in. I'm going to motivate. This is the magic sauce right here. So that homework will be magically appear into a file server, and they'll just open the homework right up. They'll just be in their homework after clicking that link. Then they're computing. These cells are live. They're running these cells. They can change a cell. So, and you can start off with like a lot of text, a little bit of code. People are like, getting their hand held, doing incremental little bits of coding. It's not like start with a blank canvas. It's like start with something ready to go. So there's a bunch of things that just happened there, and I call them all together. I'm going to call them a pedagogy platform, a way that we link all these things together. They're built with the vision of inclusion and accessibility in mind, and they're built so that any student can run it without having a license. It's also built to be scalable. So remember, they were building these tools when there was 100, 200 people in the class, but because they're built on these really robust open software platforms, they scale really well to 1,500 people. There was a giant struggle to debug everything when things were down in the 200 people, and keeping the data hub running was, it was crashing when there was a midterm or something. But now things generally run smoothly. There's also now Data 8X Online, which is running in thousands and thousands of students. 10,000 people will sign up, 4,000 people will do some of the homeworks. And it's still scaling relatively well. So it's a set of tools for active learning in this 1,500 person class, but then with this built infrastructure, there's a whole bunch of connector classes, and there's a whole lot of modules. So there's a lot of other notebooks that are just leveraging this infrastructure that's built. The other parts that to think about is, so there's a free textbook that's built and hosted on GitHub that saved the students a lot of money. There's a whole bunch of these tools that have been developed for Data 8 that have been fed into this open source stack. So other universities are adopting this. Other universities are adopting what things have been figured out in grading or deploying the Data Hub, the Jupyter Hub tools. And we're building a whole bunch of awesome curriculum for modules and connectors that's also sort of open source and shared with other universities. So we think this is a tool that can be used for pretty much any type of class. So what are we doing here? So it's based on Python. Python is industry standard thing that people in data science are using every day, right? So we're using a programming language that we think is easy for people to learn. We're starting them in a simple package, but it scales really well to them learning the more advanced packages as time goes on. Then we're using Jupyter notebooks. And so we're in a unique opportunity, or we're in a uniquely blessed position here at UC Berkeley that key members of the Jupyter team who've developed this technology are on our faculty, are sitting at bids working. And so we have human resources with a long thread of supporting this project. What's awesome about Jupyter Notebooks, you can make really rich curricular documents with it. So you can put LaTeX in it, you can put images in it, you can read data sets in it in a way that's super invisible and easy for students. So you can make beautiful things that look like journal articles or look like textbooks, but they're live computing documents. And I can go on for that for a while, but in academia, in the university, this enables a big shift in what teaching materials are, right? You can have people using as teaching materials things that are recently submitted for publication. You can have people using as teaching materials things that replicate actual results in journal articles. We're sort of iterating towards that, but this tool is going to be robust and it's going to be with us for a while. It's going to enable a lot of curricular innovation. So then we have, for Jupyter, to deploy it all, there's a Jupyter Hub, UC Berkeley managed server. It authenticates using your UC Berkeley email. Looks like this got cut off by the logo. Your UC Berkeley ID is used to authenticate on a server. The server doesn't sit in any closet in UC Berkeley. It's hosted in the cloud, but it's managed by sysadmins here in the division. And that is a way that students have a file server and a certain amount of compute power available to them to do all these homeworks. and professors have a way to deploy a class without really doing much more than sending us an email and asking to add their class. GitHub is a place where all open source software projects are generally hosted, or many open source software projects are hosted. It's part of the workflow that's sort of embedded in all this. So the people who are running DataHub and managing DataHub, that's their workflow and that's where their tools are. Importantly for us, while we develop curricular materials, we put them on GitHub in a public repo, and that's how we deploy them. With step 5, this interact link, where it's just a tool that allows DataHub to pull a set of materials from GitHub. So this is the step where the students just see a link. That's all they see, and they get their curricular materials. And finally, the last but a super important part of this pedagogy platform is the awesome students that we have. So we have students that have been through Data 8, many of them, few of them that have been through Data 100, that are sort of like more core engineering. And they are amazing at like collaborating. They get units, they do it for volunteer, they do it over the summer. There are all different ways students come to us. They get awesome experience. It's really good for them because they get like deployment experience and they get to practice and learn new things in data science. But they build the great materials that we then deploy. So going through the elements really quickly, why Python? There's other questions of why Python instead of R. We also support R. We also want people to adopt R as well. Our main thrust is Python because of the way it's definitely more readable and more, it's more convenient for teaching like basic elements of computer science, like scripting and looping and logic and stuff. The class is simultaneously teaching computational thinking and inferential thinking. And so Python's really good for teaching the computational thinking part. They have created a simplified, reduced package that's got the strange name of data science or tables, which are both really horrible names because you can't look up something called data science or tables. But anyways, it's really simple. Basically, they've taken a subset of commands and made it much simpler to do things with a single line of code. So whereas in Matplotlib or Pandas, things might have multiple lines to them, they've sort of made a simplified subset for teaching Data 8. And there's debates about this, and I'd be happy to engage upon it. But basically their vision was like, teach the students the simplest way so it's the most accessible. And if they, after Data 8, on their way to Data 100, need to learn Pandas, that's fine. If they're going to learn R to go into economics or something else, that's fine too. But this, teaching some basic concepts in a simplified way. So Python has a lot of packages. In Data 8, they're basically using NumPy and Matplotlib. Those are the two main packages that they're going to get exposed to, but those are like really fundamentals. As I said, when you go to Data 100, you get to Pandas, SciPy. There's also Folium, like a mapping one that's in some of our modules. Obviously, scikit-learn and sort of like how can we teach students machine learning, or like where should students get exposed to machine learning, or what's the right level of upper division class for machine learning. It's clear that like machine learning is going to start to permeate more and more of our fields and sort of doing things in a like classical statistics way is going to have to compete more and more with machine learning techniques. But operating in Pandas or operating in R, it's a really easy and flexible way to sort of blend those approaches, like the newer, less parametric approaches with the more traditional statistics approaches. They can sort of overlap in a way. So the Jupyter Notebook. The Jupyter Notebook was built largely for the concept of scientific reproducibility. So the idea was, there's sort of a crisis in some of the sciences about reproducibility. It's really hard to reproduce somebody else's code. And so this was built for like, I'm doing my analysis in a real Python IDE, but I need to develop some reproducible document to show other people what I've done. That was sort of the idea behind Jupyter Notebooks as it got started. A place where you can combine the code that gets it done, sort of like a description of it, the code that gets it done, and then the output is in there. Like the graph that's the argument or the graph that's going into the journal article is embedded in the same document. And you can change things and rerun them and still see that graph. A lot of the IDE or the previous workflow is like the graph gets generated into some PNG that gets posted into a paper later, and so you're losing that real time, like understanding the code, generating things, and seeing it all. There's a whole bunch of advantages to Jupyter Notebook that are amazing for pedagogy and teaching that just sort of like come from the infrastructure of the way that it was built. And this ability to like describe the problem, motivate something, have some code, and then have some sort of output that you're trying to teach the students, like all in line. It's also a really elegant interface. This is sort of like also something that's sort of to discuss, but other classes that I would say teaching with RStudio, it's cluttered. There's a lot of things going on in RStudio. You see the files, you see the data set. It's really powerful if you're a data analyst to have all those things in your IDE at your fingertips. That's part of your workflow. When you're teaching, it's really powerful to have a really elegant thing that looks like a single sheet of paper. That's not that different from the piece of paper we used to hand out. It's clean. It has a linear flow to it. It doesn't have the clutter of a bunch of things that somebody who doesn't know computing doesn't know about. That's like a whole interesting thing about computing is like, how can you reduce what people see to what they need to do the homework? Not like, oh my gosh, what's this complicated program that I don't know how to use? Like, here's just the few commands that I'm using just for homework 1. So it's like reducing cognitive clutter is part of what's the elegance of Jupyter Notebooks. So we can look at a lot more of these. There's a whole interesting thing that I won't demo here, but I'd be happy to demo for people, where you can put widgets into notebooks. And this is like a big frontier where then there can be checkboxes or drop downs or ways that people can change which variable they're looking at that doesn't require the coding even, that makes figures and graphs and stuff really like so people can customize that, with sliders and things that they're familiar with. We have a whole set of notebooks that we can demo different steps of that. Interesting, like the Jupyter team who works on widgets is around, so we've been talking with them as well. Data 8 is like pedagogically not on the widget side, right? So Data 8, there's no widgets in Data 8. There's no checkboxes and click. There's very little of that. There's like students need to learn all of the different basic elements of code. But as for my econ class, I was not trying to teach people coding. I was trying to get them the concept of consumer surplus. And, so I was like happy to put a little slider in there that would like shift the graph and things would recalculate. And I was like much more on like them just getting the content and then getting the code. So again, this is like a pedagogical question of like whether it's the right place, whether widgets and that sort of like clickable interactivity are the right place or not. So here's our server. We can all like log into this in a little bit. Mine is really messy because I'm really promiscuous with my Interact linking. So I have a long list of notebooks in there. The first time you log in, this will be blank. But it's also just think about like students have a file server that they don't know about. Like they have a Box account and they have a Drive account and they have all these other, they have places they could put files on bSpace as well. So there's a file server that's there for them. One thing that I like to think about, if we could get this like set up and built by UC Berkeley and sort of like owned by ETS, students could take Data 8 their first year and then graduate doing some cool machine learning application in their thesis years later, and they would have a portfolio of all their awesome code they had done over time. We're not there yet, but it's like interesting to think about like the iterative nature of like people would have the body of code that they remember, and they're like, oh, I remember I did a graph for that in this other class. I'll go back and grab that code from somewhere else. So it's nice to think about, like, if the university, more and more classes, basically. One thing to think about, like, certainly in economics, like, if you got it in Econ 100 or your econometrics class, you would go on to the advanced classes and you would have a place to look back for that code and those tools and that applications. Everybody at UC Berkeley has this account. It's open to everyone now. It's not currently spun up individually for each individual classes. So for whatever class you're in, you'll go to the same server. This is like and also something to think about, like at the IT infrastructural level. Like some people are like, oh, well, R should be different than Python, or people doing complicated research projects should be in a different place as people just in Data 8. So for right now, we have like a single unitary hub, but potentially someplace in the future, there will be places that people will be steered into different hubs. So for the research IT people, here's a couple of graphs. This is usage over the fall semester. So this is number of users. So we're in the thousands, peaking out around 1,500 users per day. And then, there's like a seasonality, things drop off. So interesting to think about. It's, I think, pretty awesome tool that it gets 1,500 users per day and runs. I was in a class on Tuesday, environmental economics class, where we were launching a new notebook. It definitely, like, when 100 kids click the link at the same time, it definitely, like, whirs for a little bit. Like, it wasn't, like, instantaneous. But, 3-4 minutes passed, and then every kid in the class had the notebook spawned up. So it's had its ups and downs, but it's quite a robust system. Here's another interesting one for research IT. So this is an estimate of costs. I probably shouldn't be like making this like super public. This is definitely like back of the envelope. But they have a cost for how much the cloud credits they get overall are. So cost per user per day, about 30 cents per user per day. If you sum that up over a semester, it's something like $30 per student. So it's not really taking into account connectors and modules. It's basically like, this is basically like if you took the main Data 8 as the main part. We get a grant for like the bulk of Data 8 and then run the whole data hub off of that. So potentially the costs are lower because there's so many other students using it as well. But anyways, it's just a ballpark for us to think about, and like as a campus to think about. So software is all hosted at GitHub. GitHub is a place where there are many amazing things. Lots of people who are into transparency and reproducibility, like academics, are hosting their code there. A lot of different, like the new techniques and the new tools and the newest things and, Python adaptations are hosted there. So it's a natural place so the Data 8 course is hosted on GitHub. The Data 8 textbook is hosted on GitHub. And all of our stuff that we do in curriculum development for modules for other people's classes is all hosted there. So hopefully at the end I can get you to go check that out. Yeah?
Can I ask a question? So I have both the Jupyter and the GitHub open.
Yeah.
What's the connection? I don't understand.
Oh, you're motivating my next slide. Boom!
Okay.
That's like the teacher that's like the student you pay to come sit in the front and ask the question. The interact link is what joins the two. The interact link is a Python routine, again, called NB interact. It's something that was built and sort of developed here. And what it does, at one point, it pulls everything from GitHub. Everything's in a public repo. And git pull is something where you pull everything across into DataHub. So you would make a public repository, and this is what we can do later together. You would have a public repo for your class or a folder for assignment 1. And so this is for Legal Studies 190. Legal Studies 190 is the most intensive class that we've ever built. So the folders were by week, the repos were by week, and then this was the EDA. was one on exploratory data analysis. So you post a link to a notebook or a folder at the top. You create interact link. It makes this long thing. You then put that into your course website. This is what I already showed, like the interact link working.
Just go back.
Yeah.
This is the third thing. So you're in this. You have to go to that link there.
Yeah.
Okay.
Here, this is a graphic that I did to try and explain it. Okay, this is like the new one. That's like my workflow one. So you created an assignment. Now you want to get that assignment to the students, right? So you go to that web page. You create that interact link. So 2 ways that we can think about it is we go to B courses and we say create assignment 1. And assignment 1, we put that link in there and say this is due on Friday at 5 p.m. Or your course has a website. And we just looked at the Data 8 course website where it was like, like Monday, reading is this. And then there's a column that's like homework 1, right? Which doesn't see that long link. It just says homework 1, but that's like an active link. So you create the assignment. The student clicks the link. When they click the link, it goes to GitHub, gets a copy of their homework, and puts that into their file server on DataHub. Another thing that's important about this is like it's going to get every student exactly the same, a copy of exactly the same file, and it'll bring the whole directory over. So this is a big one where you're like, oh, there's 2 data sets, or there's 3 data sets, or the image files need to be in the right. There's always going to be that thing that like, if it's not just one file, like, is it in the right directory structure, or did they put their data set one directory up, or where did they save it, or there's as a GSI it can be like a headache, right? So there's like a whole bunch that's streamlined by this whole process. So a copy of everything they need for the homework, not just the new Jupyter Notebook, comes over and they're on Jupyter Hub. They run the assignment, they fill it out, they do the coding, and then they'll be like save as PDF. From Save as PDF, they can go to B courses by 5 p.m. on Friday, and they just upload their PDF into B courses. Or you can set it up on Gradescope. One thing that's interesting that I'm teaching a class right now, and in Jupyter Notebooks, there are different lengths based on how much the student wrote or how much the code is. And so Gradescope really wants things to be like in a fixed place on a page. I don't know if you guys know about Gradescope, but Gradescope is a way to grade PDFs. It's amazing because you can grade written exams, but if you're grading a written exam, it's like on the top of page 1 is question 1, and the top of page 3 is question 4, and so you can assign fields of where the questions are for when it's scanned in. It doesn't work as well for Jupyter Notebooks because there are variable lengths, and when it gets paginated by making the PDF, things end up in different places. There's ways to work with that. Data 8 and Data 100 use Gradescope quite successfully. So these big classes are using Gradescope because when you get 1,000 kids, you have to use Gradescope. Is this helpful, Sophia, the workflow thing?
We will always have to use the Jupyter Notebook. That was my question. You can't just have everything like in R on GitHub. You will have to use.
Well, you could use RMD. So
but I can ask that question at the workshop.
You can definitely do things in R this way.
Okay.
It doesn't need to be in Jupyter Notebooks.
All right. Thank you. That was my question.
Yeah. It will basically pull a file, like, I don't know the language, a file, folder, a repo. It'll pull a folder over for your assignment. If you're in R Studio, for example, this is just an aside, DataHub can also host R Studio, which is going to make more professors want to play with us. Then they will see their file directories in the bottom right corner of the RStudio on DataHub, where you would see your files in RStudio on your desktop. And then you can go into that repo and open those files as needed. So a very similar thing happens. And I don't have the demo for that here, but I can demo that for you in person. So really quickly back to the accessibility. It's sort of like the diversity and like data science for all. So the previous way, like say our homework is in Stata, say our homework is in like the previous way where they need an installed software. First day of class, the GSI has to wrangle with, you have to install the software, you have to get a license. You're a graduate student at UC Berkeley, you better steal somebody copies of Stata like the day you get here so you can use it for all 5 years. I mean, that's what my grad school program was like, getting somebody's licensed software copy, and you're like, I'm a grad student, let me have it. There's ways that, previously was also go to the computer lab to do your homework. In the computer lab, there's an installed license copy. Then you have a thing of like, whose files are where in the computer lab. You don't need to worry about which version is installed, which packages are installed. All that can be handled centrally, so you make sure that all students have the same version, all students have the same package. Like, that's handled. Oh, it turns out that I was using an older copy, that's why it didn't run. So it's solving a bunch of these problems. There's definitely a burden on the GSIs in the class when they have to be the ones who are sort of like running the screen for the professors on like, what does it take to get all this deployed. I have a class that I just was like encouraging them to use DataHub, Econ 141, and the professor was like, install Anaconda, do the homework yourself. And I was like, all right, well, if you use DataHub, it just saves a whole bunch of time for the GSI that there's always like, those last few students who can't quite install Anaconda by themselves. It's much quicker to students. Like, students are computing quicker. Students are spending more time doing their homework computing and less time like trying to make sure that something's installed right or the thing's in the right place. And for me, encouraging professors, it's quicker and easier for professors to try something new and to adopt something new. So we just say, we want to get more people computing. The traditional way was like, there's just roadblocks that keep people from computing. How do we get more people computing over time? Benefits of using the cloud, any computer works. More and more students do have Chromebooks, More and more students do have tablets. You can do it on a tablet, you can do it on a Chromebook. All the files are in the right place. I already talked about this. Like, you need the data set to be in the right directory structure. That can be a pain. All the students have exactly the same computing environment. It's not like the person with the best computer can do something faster. Students are computing right away. And it's just a much more streamlined workflow as the class deploys something. So,
can I have a question?
Yeah.
So in terms of accessibility, does this require students to bring laptops to classes? Is this the future of what we think?
It's a great question.
I have a lot of students that say we can't afford a laptop. And if we're going more and more into I bring it like it's great to teach, but I'm always concerned about that.
So there is a system in the library where they can check out a Chromebook for the semester. And there are Chromebooks on the cart right now. I thought you were going to say, when you're teaching and everybody's on their laptop, it like takes away from your teaching.
No, I was thinking about accessibility.
Accessibility. Yeah, I would have. So me personally, I think that students should have computational skills for sure as part of.
No, I'm just avoiding the laptop. So there are ways to check out laptops.
Yep.
I've had questions of students asking me that. I didn't know that.
Yep. We need a way to make that program more visible because it doesn't get utilized enough.
Okay.
It's amazing. I've just anecdotal stories where the student's laptop or backpack gets stolen in the middle of the semester, and then they can like continue on the class because everything's hosted and it's all on their file server. Benefits of the cloud kind of thing. Did you have a question?
I was just going to say there is a student computing at Cal program that is looking at that exact problem to improve accessibility of that kind of those kind of computational resources for students that can't afford it. It's super cool.
Thank you.
And there's always been labs. It's just like labs are used less and less and less, and so some of the labs were underutilized, and some of those spaces they're like turning over, to classroom use because the labs. I mean, I don't know. 20 years ago, there was like more labs than there were today.
And I was shocked because I went to the OCF like at 5 p.m. one day this week, and it was mobbed. The lab was mobbed, and I said, I thought that labs weren't a thing anymore.
Yeah.
And they said, no, it's really super popular with the students.
That's cool. Go OCF.
What's OCF?
It's the Open Computing Facility, so it's
I'm always the one that asks questions, sorry.
And where is it?
Hmm?
Where is it?
It's in the student union building, in the MLK building on the ground floor,
Mhm.
and it's all student run. We're trying to figure out how to support them and look at them from the central IT side of the equation.
They support professors too. I mean, it's for everybody who works here.
Well, we were there when the Spanish department, someone from the Spanish department contacted them looking for support on Jupyter Hub.
Ooh.
And so I think Anthony, you were there, right? So
Very cool. So anyways, I don't know if, did you want to say something?
That was me. So I'm a PhD student in the Spanish department and I'm learning programming, and there are all these resources at Berkeley that we don't know about, but they are here.
Yeah.
So it's just a question of making them maybe more available for everybody, but they are there. So there is infrastructure.
Yeah. I mean, OCF's sort of an amazing thing that's been there as long as I've been around. And like, if you wanted a website like in the 90s, the OCF would host your website, and you can see some old school people still have like an OCF website. So this platform was built for Data 8. We were able to build a whole bunch of other awesome curriculum around it. So there was these connector classes. There's one in neuroscience teaching fMRIs to undergrads. There's an awesome one on sports analytics that was super popular. I taught a class on working in Africa and development economics. That's how I got involved in this. So, and then as I said, there's modules. So there's this way to deploy things really easily into a class where people are not expecting to do computation. And then now we have this idea of like, let's build classes where we're calling them data enabled, where like the vision is to have these tools used throughout. So this big legal studies class, and like legal studies, amazingly, like the amount of computation has gone up a lot. There's a lot of people in law school who do not want to touch a computer, but there's like this amazing class where like, prediction, text analysis, there's so many tools of data science that law is actually using. Making some slow but progress into economics. There's energy analysis. A professor took it on sabbatical, learned a bunch of machine learning, built a bunch of curricular materials with our support, and launched a new class that hopefully will grow over time to be like, another core machine learning class.
So for the data science majors, in order for our class to be part of the curriculum, would be cross-listing enough, or do we have to do an additional class?
I mean, yeah, for the, so technically, to be listed as part of the major, like if 118 was going to be listed as part of the major, there's a governance committee that reviews classes periodically and like what's on the technical class list and what's not. So we could, there's a pathway that I can help you like submit your class to the governance committee. For the major, so interesting for the major, there's only 2 classes that are owned by data science. There's Data 8 and Data 100. There will soon be a machine learning one, Data 102. But almost all the classes are taught in other fields. You can take a whole bunch of classes out in domains. So Sophia was asking, like, suppose I made my class have these awesome data science elements in it. How do I get my class listed as part of the data science major?
So related to that, are there any essential or minimum competencies or outcomes that you require for as a connector course? Do you think about building blocks for learning between Data 8 and connectors or data enabled classes? Do you have a...
It's really quite open. I mean, it's really quite open. If something was to be, so there's a computation and inferential depth, there's machine learning, there's probability. Those have quite strict requirements to like what's going to be in those. But for the domain emphasis class, like you're taking a class in a domain, that's pretty open. For the connector classes, that's very open. Like, so the data connector classes are just a very specific subset of classes that are meant to be taught with Data 8. That there's just a handful of. But if you're interested, would love to talk to you. Like if you want to propose a class for that, we're trying to recruit people to teach connector classes. So just thinking about the flow, we got a new professor here. They're going to go make a new notebook. They're going to make an account on GitHub. They're going to make a public repo that corresponds to their class. They're going to put the notebook and the data up in that public repo. They're going to make this interact link. Then they're going to post that link onto their class page as an assignment, or they can email it to their students. or they can put it on their personal page. There's some way that they're going to get that link out there to the students. If you want to work with us, so we have a team that's going to help you build stuff. So the professor comes, they bring their syllabus, they're going to bring data sets, they could potentially just bring problem sets they want to convert. The students, there's 3 of them out there looking through the door. They help to build the notebooks, they'll meet with you, they'll share them and get feedback, and then you schedule class time, and the students can come into the class and teach it in class. Then you send it out and you can collect the notebooks as a PDF file. I probably need to hurry up and finish to get to the workshop-y part, but this again, just thinking about the pedagogy of how to teach. So when I'm teaching, I a lot of times are teaching with something's completely filled out. It's got all of the code there. Maybe it's got some widgets. I have places where people can answer stuff, what did you think of this graph? What did you conclude from this? There's other people who are programming, all of the programming is left up to the students. It just reads in the data file and it's sort of blank out for the students. So data 8 can sometimes be in between, but this is a careful thing of how do you show some of the code and then leave the rest of the code for the students to do. So this is again this sort of learning outcomes. What do you want students to get out of it? How much computation do you want students to get out of it? So there's a whole thing about building textbooks. There's a textbook for Data 8. We have a whole thing of working with teachers. So we have a whole online open textbook called the Curriculum Guide. As we get people, our mission is to get professors empowered to use this for their classes. So we have sort of free resources for them to train up on it. I've already motivated most of this stuff. If you want to come to our website and see our modules, there's an amazing amount of resources from other classes that you can copy, learn, look at their code, see how other people have done things. And hopefully we'll build more and more over time. This is our GitHub, github.com/dsmodules. So there's a whole bunch of resources for you to check out. And in the summer, we teach a 3-day workshop in this very room. Look, it's this very room. We teach faculty. We have somebody from Data 8 come in. There's 3 days of learning Data 8. There's instructors that come who have done the notebooks in their class. And then on the last day, you can actually meet with the students and think about what it's like to build materials for your class and sort of get started on that. So we're looking for people to join us. You can go to data.berkeley.edu and see what we do for modules. If you're at all interested, you can email me and I will come to your office and show you what we do and help identify what your needs might be. You can look through our library of notebooks. If you want to teach a connector class, definitely write me, and we're looking for people to teach connector classes for the fall. And there's the summer workshop that you can sign up for online or come to. So some people will need to leave because it's the hour. Sorry about that. If you want to do a little bit of workshop-y stuff, go to this little tiny URL and I will help walk you through some of the steps of what it takes to do stuff. And I don't know if there's AIS laptops. There's some students that can help us as well.
What's the website to sign up for the summer course?
Oh, sign up for the summer course. If you go to data.berkeley.edu, here, let me, you can email me and I'll send you the link, or if you go here, Education Pedagogy Workshop Series. So it's under the Education tab and it's called Workshop Series, and you can go down to a short summer workshop, June 30 to 5, 2019. And there's a sign-up form right here.
Would it be competition, like how many people you're going to admit?
Yeah, it's limited by this classroom, so it's about 40 people that come. But yeah, some people, most people make it in. It's not. There's also a one-day grad usually I run a 1-day grad student one, so I can send some people to the grad student one that don't come to the 3-day faculty one. But yeah, are you a professor? A postdoc or?
Yes.
Okay.
Postdoc.
Postdoc, awesome, great. Yeah, I'm sure there's almost always room. We'd love to have you. All right, so did you want to try and make the interact link?
Oh, you're talking to me?
Yes.
Yeah.
I'm here for you.
Good. I just have a question before that.
Yeah.
My class, actually, I want them to code,
Mm-hmm.
right?
Yes.
So you said, how much do you want them to see? I want them to see a lot. What I need help with is that thing that everything's at the right place and they can change little things.
Yep.
And I have everything in Stata right now, but I just learned R a couple of weeks ago, and
Yep.
I've been slowly transferring everything to R.
Yes.
So I'm definitely going to do the R Studio.
Cool.
I'm very reluctant to want to learn Python and do everything in the notebook, but I'm willing to be.
Well, you can
convinced-
also do the notebook in R. That's another confusing thing.
Okay, that
That's a
helps.
pedagogical choice.
That helps because and the students can code in R as well.
Yeah.
That's what I need them to do.
Absolutely.
And it's not possible to stick to Stata.
No.
Okay, that was my final question, and so yeah.
There is, if anybody's like really interested in the Stata, there is on Haas a Stata Jupyter notebook that you can demo just to see it. It's cool to see that you can run Stata in a Jupyter notebook. For me, because Stata was like what I learned when I was in grad school.
Yeah.
So it is possible. We don't support it
You don't support it
because of the whole licensing thing.
Got it. So you would be doing something illegal, which I'm doing right now with my class. And you didn't hear this.
Right. I mean, but whatever.
Recording
People have
it.
been copying each other's Stata licenses for as long
You
as
probably have mine too. So.
there's been a Stata license. Right.
All right, that's why we don't support it. Got it.
Yeah.
Okay.
So wait, do you?
I have a
This is
GitHub account now.
yeah.
We're in the workshop mode, right? I don't want to monopolize this.
It's
Just
okay.
do whatever you were thinking of doing, and then I can ask. Don't worry.
So
But I'm not in Berkeley. I'm in some Esperto 2019. It's my own GitHub, right?
Esperto.
Sorry.
Can't find you.
It's not in Berkeley. that's
Oh,
what I'm saying.
users. Yeah, users. There we go. Users.
It's private.
Oh, it's private, so I can't see it.
The reason it's private is it's not ready for public viewing.
But she 4 deep 147.
Well, I downloaded that one because I wanted to see how you did the Jupyter.
Yeah.
But it was, when I had it, I don't think it was ready to go yet. So,
It's now been launched. The students have it in their hands.
so maybe if I see it again, maybe I will convince to switch to Jupyter then.
Yeah, I want to convince the Data Hub people to add R to Data Hub.
Please do that then.
I know.
What's stopping them? They don't know any R?
Okay, so this is just to show somebody who cares. This is, you can see R Studio in Data Hub.
Oh,
This is super cool.
Yeah,
This
with
is
Switch,
the
right?
file server where the interact links go to. So if she has her class here, it would be like 118 would be right here. And then you would click that open, and then the R files would show up here.
Should I just change this to be public then?
You should make a new one that's public that you're going to call like demonstration or something.
Okay, so I didn't.
But here, let's go with.
I was trying to do a Jupyter thing. That's why I didn't know I could do R in here as well. So what did you do to? So
All right, let's Sophia, let's move back. Okay, so let's go to Let's go to this link. It's in the site that I sent you, and you go to the DS module site. So you guys can go to the DS module site, pick a class that you're interested in. Sophia is interested in EAP 147. Alec in the back of the room is the lead developer of EAP 147. Okay? Okay, so then, oh look, in the README file, there's already an interact link. That's cool. So you can also click on this link and it will open in Data Hub directly. But what we want to teach you today is how to do that yourself. Okay.
And you didn't do it in R, it's still in Python, right? So you don't have one in R where I can you just point me to one that has R? Or it's none?
You want me to do something on the fly?
No, don't do it now. I'll email you, don't worry.
I have Ted's ones are in R. Ted Miguel's 171 one. But we can look. There might be one on here.
Follow your script. I don't want to derail the workshop.
Econ. Let's see what we have for econ. I don't have it here. Okay, so according to my script, go to this link if you can. This is one of the other links on the page, URL to interact at Heroku app. If you wanted to start with 147, you could go into lab 1. This is really annoying, the Zoom thing. Can I just stop the Zoom meeting?
Yeah,
Or
sure.
are we?
Actually, yes, the two people who were on Zoom have left,
Okay.
so go for it.
You're going really fast.
Sorry. Okay. So I'm in the place that I want to be on GitHub, where the files for the class are. Does that make sense?
Yep.
DS modules, EAP 147, lab 1. So I'm like on the first homework page. I'm going to copy this link here. It's creepy when I'm like whispering into the microphone. Here we go, you're on. And I'm going to paste it in here. Copy the URL for that repo. Convert to interact link. Sorry. So if you go to this site, all of these things are linked on here. But URL to interact Heroku. Or you can go to this tiny URL, UCB D7. You got it? So we're making an interact link using URL to interact. Which is in this tab. We're pretending this is our class and this is assignment 1. So we pasted the repo we want to go to. Students are going to get this link in their email or from bCourse's announcement or whatever it is. Oh, what did I do wrong? Sometimes you have to just do it for the whole class, not for the sub. So if you do it for the whole class and not for just lab 1, it works.
So well, I was doing that's now I don't think it was ready.
Can I just go back to the
Yeah.
when I opened up the 147, just on your you got it up.
I learned a lot.
Just correct.
Yeah, sorry, yeah, file server.
Okay, go back up one level. Yeah, that. But you've got a couple files that I don't have. The LSA, Open Science, and requirements for the date stamp aspect.
So I have,
Yeah, I don't
No.
have that either. I don't have that either.
I've been messing around for a while, and I've had a directory called EAP147 for a while, and I had other things that I was doing. So I just clicked on too many interact links, too many git pulls. So it's not going to overwrite what's already there. So it's sort of smart like that, where it's like, you're going to make a new copy of your notebook, or you're going to do something else inside your file server. It's not going to overwrite what you have. So that's probably why that is.
Just a question about that. Is working and then once, like in a joke notebook, you can save.
Yep. Oh yeah. So there's lots of great
And
questions.
That gets sort of saved back to this.
Yep. Save as, make a copy. So those are both really important. This came up the other day, and we should potentially document this. Where like, make a copy where you do something else, or like, save as something else, rename it to be something else. So that's like a, definitely like when the students were like, oh, I messed something up, I want to go back to the original.
Right.
And so this would be a way, make a copy, save a different one, checkpoint it, revert.
You're saying save as PDF, that's really download as PDF?
Yep, download as PDF. And there's a lot of options. Download as HTML is also really good because that renders nicely, but PDF is just an easy way to grade. It's a way that grading is done a lot. There's a little funny thing with Jupyter Notebooks that's not super elegant. That's about, it uses this renderer that comes from LaTeX as the thing that makes the PDF, because sometimes it has to render equations, and because of that, it needs to send them to LaTeX. But because it's like a LaTeX engine, sometimes other things don't render gorgeously. So that's like something that I would love to have like an upgrade, is like the PDF maker attribute of Jupyter Notebooks.
I have a question. Is it possible to do, imagine for a quiz, just to see if the students are on par with the class, to have like an interactive click, and instead of grade scope, they would just respond, and then it would be graded automatically, or do people do that?
Yeah.
That's what you meant by widget?
No, well, this is like a whole important topic that I just glossed right over. There's one for the coding side that's on the data, like in all of the data 8 lessons, there's some auto grading going on. So, and this is standard in most computer science classes, or suppose there's like a really long thing that you need to do. But you better make sure that like the routine that you built in Unit 1 is going to run in Unit 2. And the thing you build in Unit 1 and 2 is going to be really important for Unit 4. So you want to make sure that sub-chunks of code are going to run correctly. So there's ways to program that in that we have for Python that we don't have for R. Supposedly some people in public health have figured it out for R, but we haven't quite documented that. Where the students in the coding cell can get a check and, be like, is your variable name within some bounds the right variable name? So in the data 8, this is really important, auto grading. It's also really important in teaching a 1,500 person class, where like they can grade some answers, but they need a lot of the parts of the notebook to just grade itself.
So it doesn't go to grade scope, it's happening within your Python code.
It's happening with your Python code. Where it goes is a whole interesting infrastructural can of worms that I'm not going to get into. But the current deployment, it grades on the same UC Berkeley data hub. The previous deployment, and I think the way Data 100 is working, is there's another server called OKPy. And students send their homework to OKPy. On OKPy, it runs the notebook and checks against these 10 tests in the notebook. So that's like a whole like technical solutions thing that we're still working on, and we have people working on, and it's definitely like the killer app for this. Like instructors want auto grading. You know, we're like, okay, I'll grade a couple things, but let's like have the auto grader grade all the boring part, or you know, check where they are, or make sure that they're on the right track. It's more in the computer science. It's more like, are students on the right track? Like it gives them some checkpoints along their homework to be like, oh, you didn't get this step 1 right, so don't keep going. Yeah.
Right, cool.
Cool. Thanks for coming.
Yeah.
Thank you, guys.
Sorry for going long. Did you have any questions? Did you want to demo anything? You're good?
Me?
Yeah.
Oh, yeah. I was just going to mention, I'm the service lead for Gradescope here, so that was kind of my interest in it, and it sounds like, because I know Gradescope has auto-grading functionality, but I don't know.
Tell us about that.
I don't know how it's being used on campus.
Who can we ask about that? Or who's like, can you facilitate a conversation?
Yeah, definitely. I can connect you with like my contacts there, and we can identify like who's
And
actually
where are they?
using it.
Are they in Berkeley?
Gradescope is in Oakland, yeah.
Yeah.
Wow. Thank you, sir, for your service.
Well, yeah, because that was why I came.
I see
here.
that on Gradescope. It's like auto grade your code, test your code, and I'm like, oh, I don't know how. We're not using that.
Yeah, I know there are a couple of classes that are using it, but it's technically over my head, and I don't know. And
Do you know what classes they're using it?
I don't think I have that on my notes, but I could quickly find it out.
61B uses it. And do you know how it works? Like they run the notebook at Gradescope?
You have to push your code to GitHub, and then Gradescope will pull your code, and it'll run your code against the tests. I don't know the backend.
Yeah.
VA is also using it. But we're using it, like we generate a token locally, and then we send that token to Gradescope, which turns it into a score, I guess. Yeah.
Oh, your grading generates a token.
So we locally generate this like long, like unreadable file of text.
Yeah.
that we send to Gradescope.
But Gradescope's not doing the testing in that, testing the code there.
I don't really know what it's doing, but it's reading this token.
Yeah.
Yeah, it's like converting the token back into the code
Yeah.
that it's running or something.
I think so.
Huh. Yeah, unresolved. Gradescope has been so promising for so many people. There's a chance. I would tell Gradescope, like, make auto grading a priority because people want it.
Yeah, the few conversations I've had around it, I think, are that the people who have done auto grading and are doing it now have just like built this entire ecosystem themselves.
Yeah.
And so to convince
Bye,
them
Sophia.
to pull that out and kind of make it talk to their system is, there needs to be motivation there to do that.
Yeah. Yeah, I mean, so that's like Data 8 and Data 100 like periodically revisits this. But the system they use is like held together with duct tape and string and,
Yeah, it seems like if
was
there
purpose built at some point.
If there are limitations in computational resources, then it seems like Gradescope would be able to help that with things. They're just running up the really fast.
Right.
And Gradescope whenever they can scale it, they depend on them to do that.
Right. Yeah. So Gradescope, yeah, that's interesting. They're gonna need more compute power. Because right now, you just have like a campus contract with Gradescope.
that's not
It is.
scaled to like how computational classes.
We're just trying to figure out where the file might be.
I mean, I think they,
If you end up
even there, like, it was,
Did you-
it was founded here, and so like they're Berkeley CS students, and I think they're pretty familiar with like what's going on here.
Right.
So I don't think, if we were to say, we want to start using this for data aid or something, they would know what that means.